Hello, welcome to today's lesson. We will be focusing today on solving inequalities and compound inequalities. So the first thing we're going to start with is our vocabulary. First word, inequality. This word should be familiar to you. An inequality is simply an expression that contains a less than or greater than symbol instead of an equal sign. No more equal signs, only less thans and greater thans. Our next vocab word is a compound inequality. Compound means that we are taking two inequalities and they are going to be joined using the words and or. So you're going to see problems where there is either the word and or somewhere in your problem. And one of the first skills that you are going to be focusing on for your first example is learning how to take words and translate them into symbols. So this first chart kind of gives you an idea of the four main symbols, what their names are, because we all know you're not so familiar with the names, and what they look like on a number line. So the first symbol that we see is this symbol right here, and in terms of what word that is the word greater than. And if you notice on the number line, you have a dot where the 4 is, because that's what this problem had, was the number 4 in it. And because greater than is bigger, we have a shaded area going to the right. Our next symbol looks the same as the one we just saw, only it has a line underneath it. So it is still a greater than, but that line means or equal to. So if you look at the number line, they should look similar. And a matter of fact, they do. There's only one difference between the first number line and the second number line, and that is the actual dot. If you notice the first number line, that kind of looks like a dot that's not filled in, which it's not. The second dot is. So that is the big difference between these two symbols. The one without the bar is not filled in. The one with the bar is. Let's look at the next symbol. Right there. And that is your less than symbol. The arrow points to the left. Left starts with L, less than. So left and less than should maybe help you remember the difference. And if you notice, the number line now looks a little different. We still have a dot at the 4, but now because we are going less than, which is to the left, we are shading left. Our last symbol just throws that bar underneath, which means the only words we are adding with less than is the or equal to part. And just like the first two, this last one, the only difference between them, the no bar has the open dot, like this third line here, and the fourth bar has a filled in dot because it has a bar underneath it. So we are now going to turn and look at several more words that represent these same symbols. So let's take a look at some important words. First sentence, X is at least 3. When you hear the word at least, you are using the greater than or equal to symbol. Y is at most. When you hear the key phrase at most, that is a less than or equal to symbol. Z is between. When you hear the phrase is between, you will see a Z or whatever the letter is in the middle, and you will see the low number on the left, and you will see the high number on the right, and you will see two less than symbols, not less than or equal to, just less than, between them. X is fewer than. Fewer than means less than. Y is more than 9. More than means greater than. Z is no more than. There's your less than or equal to again. And X is no less than. That is greater than or equal to. All of these 7 phrases will appear in your notes, in your homework, and on your test. It is your responsibility to memorize what symbols go with what phrases. And yes, you do need to know them. So what we're going to be doing today is solving and graphing on a number line. So that's the last little bit of introductory notes we need to learn, is how do you graph on a number line. First step, you got to actually solve. Get x by itself. This is the same set of solving rules that we applied last class. You still have distributing and combining like terms and moving a variable and solving your two-step equation. Once your letter is by itself, the next thing you do is you make your number line. The first thing you put on your number line is a dot. If you notice on the previous slide, we had open dots and closed dots. Open dots are used when we have no bars. In other words, less than and greater than are open dots. Closed dots are when we have our bars. So less than or equal to and greater than or equal to. And again, those are things that you need to have memorized. We also have shading. There's two directions you can shade. You can shade to the right and to the left. On a number line, if you go to the right, you are getting bigger. Bigger is greater than and greater than or equal to. If you go to the left on a number line, you're getting smaller. To the left is less than and less than or equal to. If you notice, these kind of look like arrows. The first two are pointing to the right, which is why we shade to the right. The bottom two are pointing to the left. That is why we shade to the left. So that being said, let's take a look at some examples now. Example 1, we are going to write the inequality that represents the sentences and then solve the inequality. So let's take a look. We have the sum of a number and 5 is less than -7. So the first word I see of importance is sum. I would hope that from middle school in Algebra 1, you know that sum means you are adding. Well, you are adding two things. You are adding a number and 5. Well, when you hear the phrase, a number, we don't know what number you're talking about. And when we don't know what you're talking about, we always use a variable. So the two things that we are adding are a variable, which I'm just going to use the letter X, and 5. Then, if we keep going, it says, is less than. There's your symbol, less than -7. So I just took a sentence and translated it into symbols. Now, we have to solve that inequalities. In other words, I want x by itself. Well, the only thing that is keeping me from having x by itself is that +5. The opposite of adding, I'm going to subtract 5 from both sides. So I am left with x is less than -12. Pretty easy. Let's look at B. The first word I see, the product of a number and 8 is at least 25. Hopefully you learned that product in math means multiply. You are multiplying a number and 8. We just talked about a number means x, and 8 is already given to you. And then we see the phrase is at least. That's one of those phrases you have to know. If you need to look back, at least looks like it's here at the very top. So at least is greater than or equal to. And then we have the number 25. Well, we got to solve again. The number with the x is the 8. It's multiplied, the opposite of multiplication. We're going to divide both sides by 8. And if you type that in your calculator, you should get x is greater than or equal to 3.25. And that's where we're going to stop. Last problem. The quotient of a number and 12 is no more than 6. We know quotient means division. Well, in high school, we don't use old-fashioned division symbols. In high school, we use a division bar or a fraction bar. So we are dividing a number and 12. So x divided by 12 is, here's our phrase, no more than. So let's look back. No more than is second from the bottom. No more than means less than or equal to. And we have the number 6. So now to get x by itself, we need to get rid of that 12. The opposite of division, multiplication. So I'm going to multiply by 12 on the left and on the right. And I get x is less than or equal to 72. So those are your first type of examples you will see in your homework. Translate the words into symbols and then solve the equation. So let's move on. So let's take a look at example 2. We will do the first one together. We need to solve and then graph. Now these problems have a very, very important rule that hopefully you've heard before. Don't forget, when you divide or multiply by a negative number, you must switch the sign. Okay, that is very important. That's only going to apply at the very end of your problem. It's the last step of your math. If you divide or multiply on the last step by a negative number, you must take that sign and switch it the other way. So let's take a look at our first example. Just like last class, put your line down the middle. And we start with distributing. I'm going to distribute the negative 3. Negative 3 times 2x is negative 6x. Negative 3 times, that is negative 5. A negative times a negative is a positive 15. Bring down the plus 1 because we haven't used it yet. Bring down your symbol and bring down your 4. So that is distributing. Remember, the next thing we look for is like terms. Well, on this left side of your problem, I see a pair of like terms. They are like terms because they are whole numbers. So I keep the negative 6x. 15 plus 1 is 16. Keep the greater than or equal to. Keep the 4. Now I have my two-step equation. I'm ready to finish the easy solving. I need to move the added number first by subtracting. I bring down the negative 6x. I bring down the greater than or equal to. 4, take away 16, leaves you with negative 12. Now we have to divide. Notice I am dividing by negative 6. The negative 6 is canceled, I'm left with x. Here's where we pause. We just divided by a negative number. So according to our rule, since we divided by a negative number, this greater than or equal to symbol now points the other way. A negative 12 divided by negative 6 is a positive 2. So that's the solving part of it. Nothing new except for the dividing rule. Now we need to make a number line. Now I allow you guys to make what I call a lazy person number line. You don't have to put a whole bunch of numbers on your number line. You take your important number, which is the number 2, and you put it in the middle. Then we need a dot. Remember we talked about open and closed? Well, if we look back at our rules, when we have a bar underneath, we have a closed dot. So we are going to make a filled in dot at that 2. Then, because the arrow or the symbol is pointing to the left, I am going to shade to the left. And that is all there is to it. So pause the video. You guys try part B on your own. And then when you are done, start it back up and see how you did. Okay, so let's see how you guys did. I'm going to put up my line in the middle. Keep my 3. Bring down my greater than. I need to distribute. Negative 2 times x is negative 2x. Negative 2 times positive 9 is negative 18. Bring down the plus 5. Now we need to combine like terms. Keep the left side the same. On the right side, I see a pair of like terms that are both whole numbers. Keep the negative 2x. Negative 18 plus 5 is negative 13. Now, I need to solve for x. Well, I need to move that subtracted number first. I'm going to add 13 to both sides. That leaves me with 16 is greater than negative 2x. I now need to divide both sides by negative 2. 16 divided by negative 2 is negative 8. That symbol, we just divided by a negative, so that symbol needs to point the other direction, and we have x left on that side. Notice I kept x on the side that it started on. Now, when it comes to making the number line, though, we want x to come first. So all I'm going to do is I'm going to take this entire problem and turn it around. I'm going to start with x. Notice the big part was towards the x. I'm going to keep the big part towards the x. Then I'm going to put the negative 8 on the other side. This is the part you're actually going to graph on the number line. And it'll make it easier to graph on the number line. So hopefully, if you weren't able to make your number line, you can do it properly now. Negative 8 goes in the middle. First question, open or closed? Well, no bar means open. Next question, which way is that arrow pointing? That arrow is pointing to the right, so I'm going to shade the right side of the dot. Hopefully you got that problem correct. So let's move on and let's look at an example that involves a word problem. Now we all know word problems, every student seems to think they're the hardest thing in the world. Most important thing you can do with a word problem, read all the way through it first. A movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as desired, or you can pay $15 a month and $1.50 to rent each movie. We are trying to figure out how many movies must you rent in a month for the first plan to cost less than the second plan. So I always start with the question. The question is wanting to know a couple of things. It wants to know how many movies, and it wants to know when the first plan costs less than the second plan. Those are the 2 really important things. So I'm going to use a little bit of symbols to start with. I want to know when is the first plan, here's my first symbol, less than second plan. Notice I just took a little bit of words, changed them into a symbol. Now our focus is going to be on the first plan. We're looking at the right side, or sorry, the left side. So talk to me about the first plan. It says you can pay $36 a month and rent as many movies as you desire. $36 is all you pay. You don't pay anything else. So the only thing that we can write down for the first plan is it costs me $36. I want to know when $36 is less than the second plan. Well, the second plan, you can pay $15 a month and then add to that $1.50 to rent each movie. So we start with $15 and we're adding to it $1.50 for every movie. Well, here's the thing. We don't know how many movies. That's what I have highlighted is how many movies. Since we don't know how many movies, we're going to put an X with that $1.50. And now that we have an inequality written, now we can simply get X by itself. So the first thing I need to do is move that 15. Let me put up my fence. 15 has got to go to the other side. I'm going to subtract 15 from both sides. That leaves me with 36 take away 15 is 21 less than 1.50 x. Well, now I need to get x by itself. Divide by 150 on the right. Do the same on the left. That 21 divided by 1.50 is 14 less than, and we have x left. So it's easier to read these when x starts. So again, we're going to turn it around. I'm going to start with x. The open part was towards the x, so I'm going to keep it towards the x. 14. So what this says is x, which is how many movies we need to rent. We need to rent greater than 14, and I'm going to put a label there of movies. So really it's not as hard of a word problem as most people think. Everybody hears word problem and they freak out. All right, so let's look at the next example. Directions should sound familiar. Determine whether the following inequalities are identities, which we learned was true statements, or contradictions, which are false statements. We did this in the last lesson. If you remember, these true statements and false statements were when all of the letters disappeared. So we should have all the letters go away. Let's take a look at the first one together. Let's go ahead and distribute. Negative 2 times 3x is negative 6x. And negative 2 times positive 1 is negative 2. Keep the symbol the same. Keep everything else the same. Distributing's done. There is no like terms. So now I want all of the x's together. I want to cancel this negative 6x right here. So I'm going to add 6x. Those cancel. But on the left side, negative 6x and positive 6x cancel again. Now it leaves us with negative 2 is greater than 7. This is where we have to make our decision. Is negative 2 greater than 7? And the answer to that is no, it's not. This is a false statement. And false statements up here above are contradictions. So go ahead and pause the video and try example B on your own and start it back up and we'll see how you did. Okay, so let's take a look. How did you do? Hopefully you put your line up. You distributed and got 10x minus 15 minus 7x is less than or equal to 3x plus 8. After you distributed, you should have looked for like terms. 10x minus 7x leaves me with 3x minus 15 is less than or equal to 3x plus 8. I want all of my x's on one side. This is a positive 3x, so I want to subtract 3x. Subtract 3x. 3x take away 3x cancels. On the left side, 3x take away 3x cancels. You should have had negative 15 is less than or equal to 8. And so we look at that. Is negative 15 less than or equal to 8? And the answer is definitely yes. This is a true statement. And true statements we call identities. Whoops, I spelled that wrong. They are called identities. Okay, so hopefully you are feeling good about those. We're going to look at our last type of problem. These are your compound inequalities. So the directions say solve the following compound inequalities and graph the solution set. So let's take a look at A. If you notice, I told you guys there would be ands and ors. Well, here we got the word and. So we literally have two baby equations to solve, and we're going to do both of them separately. Let's look at the first one. I want x by itself. I have to move the 1. The opposite is subtraction. 7 take away 1 is 6. Keep the less than. Keep the 2x. Now I need x by itself. I'm going to divide by 2 on both sides. 6 divided by 2 is 3. So we have to ask ourselves, did we divide by a negative? And the answer is no, which means the symbol stays the same. Those cancel, we get x. But to make the number line easier, we've talked about this, we're going to turn it around the other way. X starts, the open part stays towards the x, with a 3. So there's half your answer. Let's look at the other equation. Put up your line. There's only one number to get rid of this time, and that is the 3. That is multiplied. The opposite is division. Divide both sides by 3. We get x. Did we divide by a negative? The answer is no. That means the symbol stays the same. 18 divided by 3 is 6. There is your other answer. Now let's talk about the number line here. We now have two numbers. So the first thing is, yes, both numbers go on the number line. But you gotta put the smaller one first. So first, kind of go away from the middle, put a 3 at one end, put the 6 at the other end. Next, let's look at some dots. The 3 does not have a bar. No bars mean open dots. The 6, it has a bar. Bar means closed dots. Now these are special problems. They work a little differently. Let's take a look at our arrows. The 3, the arrow is pointing to the right, which means I'm going to start shading to the right. However, the 6, the arrow is pointing to the left. So from the 6, I'm going to start going to the left. What's eventually going to happen? Eventually what's going to happen is they're going to run into each other and they're going to stop. So a simple rule that might help you, and we'll jot this down up here. If you see the word and, you're going to shade between the points. If you see the word and, you will end up shading the middle. Well, I can't tell you to do B because it's different. B doesn't have the word and. However, B has both problems stuck together. So this one's a little different to solve. So here's how it's going to be a little different. Instead of putting up one line, because there's one symbol, we're going to put up two lines because there's two symbols. And our goal is always to get x by itself. That goal is not changing. The difference is x is here in the middle. I want this guy right here by himself, which means the only number that's in the way is this plus 1. To get rid of a plus 1, we always minus 1. Well, here becomes the problem. Where do we minus 1? We subtract it on both sides. If you do it in the middle, then you do it on the left and on the right. Let's see what's left. 5 minus 1 is 4. Keep your less than symbol. The 1's cancel in the middle, so we have x left over. Keep your less than symbol again. And 13 take away 1 is 12. So my question to you at this point, is x by itself? And the answer is yes. X is in the middle. There's nothing else there. This really is a done problem. This is just a different version of an and problem. So just like the first problem, we have two numbers, so we need two dots. So write down 4 first because it's smaller, 12 second because it's bigger. Both of these need a dot. The first symbol has no bar, which means open dot. The second symbol has no bar, which means open dot. And because this is an and problem, and we just wrote down the rule, and means shade between. So I'm going to shade between. And we are done with that. So now we're going to do the exact same thing, only we're going to look at the next two problems, which are OR problems. Solve the compound inequalities and graph the solution set. Now we have an OR in between both problems. Just like the ands, we're going to solve both baby equations. So let's look at this first one. If I want k by itself, I want that 7 to go away. The only way I can cancel the 7 is with a negative 7. That leaves me with k is greater than or equal to 6, take away 7, leaves me with negative 1. That is one of my answers. Second problem. I want k by itself. That 8's got to go away. So the 8 cancels with a negative 8. That leaves me with a k. I keep my less than symbol. 3 take away 8 is negative 5. We're done solving. Very easy. On to our number line. Now don't make a common mistake. Which number is first on the number line? You can't think of them as positive. These are negative numbers. So the first number we're actually going to write down is the negative 5. That's the smaller number. The negative 1 is actually the bigger number. So let's look at the negative 5. No bar. No bar with the negative 5 means an open dot. Let's look at the negative 1. The negative 1 has a bar. If you see a bar, it's a closed dot. Now, let's look at our symbols. Look at the negative 5. Which way is that arrow pointing? That arrow is pointing to the left. Well, that's going this direction. Let's look at the negative 1. The negative 1, the arrow is pointing to the right. So I'm going to shade to the right from the negative 1 dot. These look different. So let's write down a little rule. Or you shade the outsides. And you have one last example. Pause the video. You guys try this one on your own. Start it back up to see how you did. All right, let's see how you guys did. Put up your line. I need to move the 3 by subtracting. I am left with 7w is greater than 8. I need to divide by 7. And I get w is greater than, because I did not divide by a negative. That's a positive. 8 divided by 7 is not a pretty decimal, ladies and gents. You need to leave it 8 over 7. Let's look at the second equation. I need to move the minus 1 by canceling it with a plus 1. We are left with 4w is less than or equal to negative 13 plus 1 is negative 12. We need to divide by 4. Those cancel. W. Did we divide by a negative? No, we did not. Keep the symbol the same. Negative 12 divided by 4 is negative 3. So hopefully you did the solving right. Let's see how your number line looked. Again, which one of those comes first on the number line? Negatives always come first. So negative 3 and 8 over 7. Negative 3 has a bar, which means closed dot. Positive, or 8 over 7 does not have a bar, which means open dot. Let's look at our shading. Negative 3, the arrow is pointing left, so I'm going to shade to the left. 8 over 7, the arrow is pointing to the right, so I'm going to shade to the right. And we are done. Hopefully you did well on these. You are more than welcome to start on your homework, but you will have about 30 minutes next class to finish as well.